I'm going to talk a little bit about the story in this book I wrote a couple of years ago. It's called Elefanten in All, and it's a story about the history and future of life and the universe. It will be out in English in a couple of months with Springer, called Elephants in Space. It's about 400 pages, and from this clock here ticking down scarily, I've only got 17 minutes left to tell you about that story. So I'll begin the origin of scientific thought, which took place in the Mediterranean, those beautiful islands. The ancient Greeks somehow took it upon themselves to start to think about the natural world and to understand how things happened. They didn't just accept it was the will of the gods. One of my heroes is Democritus, who was the first to understand that everything around in the world was made of tiny particles, so small that you couldn't see them. He called them atoms. He believed the stars in the night sky were like our sun, and he even thought that they had planets going around them, some with life, some empty and barren. Quite a remarkable set of thoughts and thinking that began thousands of years ago. They knew the Earth was a sphere. They'd measured its size with a stick and a calendar. They knew that the moon orbited the Earth and the moon and the Earth orbited the sun. They knew our place in the solar system 2,000 years ago. They came up with many incredible inventions. Just to list a few, we have tunnels and aqueducts, winches and cranes, water mills, locks and gears, lighthouses, plumbing and showers, central heating. They even had their own shopping malls and automatic doors. This was 500 BC. Well, that all came to an end about 146 BC when the Romans beat the Greek army at that time. And that sent us into a period of scientific dark ages for over 1,500 years. Really nothing happened after the Roman Empire took hold, and I looked for a list of Roman inventions, and I found concrete was a great thing. That was it. That was the one technological advancement to come from 1,500 years. Of course, they built great machines that could kill people, and they did a lot of good work in law and order, but nothing scientific, really. 1 million scrolls were burned and destroyed in the great libraries of Alexandria. The Earth became back at the center of the universe, and everything was supposed to revolve around it, and if you didn't like that, you would be literally burnt alive at the stake. If it wasn't for the Romans, the Industrial Revolution could have begun 2,000 years, 2 millennia ago. We could have had Google 1,000 years ago. We might already be traveling to the stars and have cures for cancer and might understand the opposite sex. But no, we're stuck here at this time at our present level of knowledge thanks to those dark ages. Well, a long time passed before it was realized that you could put two lenses together to make either a telescope or a microscope. The ancient Greeks even had published a glass-making manual 2,000 years before that time. I have no idea why it took so long to invent the telescope, but it came at a time when people seemed to have the money and leisure to begin to think about our universe again. Democritus' ideas that the galaxy was filled with stars were proven to be correct by Galileo, who pointed one of the early telescopes at the stars. Isaac Newton, at the same time, he gave us the fundamental laws of gravity and motion, and really the second era of scientific discovery began in the 17th century, 16th and 17th centuries. So with our telescopes today, we can see galaxies across the universe. This is the deepest photograph ever taken by the Hubble Space Telescope. So it pointed at one little patch of the sky for a month and revealed about 10,000 galaxies in a tiny area about an eighth of the size of the moon. So here we see cosmic structure looking back all the way about 12 billion years throughout the history of the universe. We can see galaxies forming and evolving in this image. We can even look further than that back in time. This was a photograph of the universe that is a picture of the universe as it was just a few thousand years after the Big Bang. It cost $1 billion to make this picture, and you can't really see it until you bring up the contrast 1 million times. And these tiny fluctuations are the light from the Big Bang, and the fluctuations you see in the light pattern arise from cosmic structure fluctuations early in the universe. So this is a picture of the universe very shortly after the Big Bang. It gives us the initial conditions from which everything in our universe arose from. We have a good knowledge of what the universe is made of. We have the imprint of the fluctuations. All we need to really understand the origin and history of our universe is to put these initial conditions into our supercomputers and try and evolve them forwards through cosmic time to see if we can form galaxies and stars and so on. So this is what we do in our research group in Zurich, and many other groups around the world have come to this understanding of cosmology that's quite impressive. So we've discovered the universe is expanding. Its origins were in a hot, dense Big Bang phase. After 1 second after the Big Bang, our entire universe, the galaxy, all the stars in it, was in a tiny little volume, about the size of a football. We have a reasonable understanding of how stars, planets, and galaxies form, and there are some remarkable findings that are more remarkable than any science fiction story. 10% of our bodies is hydrogen created a few minutes after the Big Bang. And the other 90% of you are ashes of molecular atoms that were processed and formed within stars. So the history of the elements in our universe is an incredibly interesting story, and it ended up today, standing in this room, all of those atoms, the paths they made was quite phenomenal. In the last decade, we have determined our place in time and space. The observable universe is 13.8 billion years old. There are 100 billion light years across, and there's 100 billion galaxies, each with about 100 billion stars. It's a vast place. Even our planet Earth is not special. In the last few years, we've come to the finding that almost every star you look at in the night sky has its own planetary system going around it. 1 in 10 stars have planets like our own Earth. So I mentioned that we use supercomputers to simulate the universe. This is the Z-Box 4 machine that is housed in the institute at the University of Zurich. It was put together mainly by the students and postdocs in our research groups. So one of the calculations that we've done on this is to show the formation of structure from the Big Bang to the present day. I'll just like to show you that movie right now. So this is showing a calculation that took place using 6 months of supercomputing time, using 2,000 processors. It's a tiny patch of our universe that we're simulating. There's about 1 billion particles in this calculation that represent the motion of the material in our universe as it expands in the Big Bang and then comes back together to form a single cosmic structure. This calculation, it took 6 months on a supercomputer. If we had used the fastest PC that you have available, it would have taken 1,000 years on that machine, which is why we piece together many different processes together and link them together with a fast network in order to do these calculations. So I've mentioned it's extremely old, 13.8 billion years old, and it's hard to appreciate what has happened in the time since the Big Bang. So one thing we can do is compress the entire history of the universe into one 24-hour day. So each hour in this day will be 570 million years long, and each minute will be 10 million years long. So at midnight, we have the appearance of space, time, and matter. The Big Bang begins. It's not until 20 past midnight that the first stars form and begin to light up our universe. Everything is completely dark until that point. 9 o'clock in the morning, before most of the stars in our Milky Way have assembled. During that time, there has just been the formation of countless stars and galaxies. Even within our own galaxy, our sun and solar system don't form until already the late afternoon, 4 o'clock on this 24-hour day. About 10 minutes later, the surface of the Earth has cooled down, and we have evidence for the presence of oceans and atmosphere already over 4 billion years ago in real time. It takes life quite a while to get going. By 5:30 in the afternoon, we see the first evidence for microbial life on Earth. Not until 8 o'clock in the evening that we see the first evidence for complex multicellular life, creatures that live in the ocean. The advent of animals didn't occur until about 11:05 on this timescale. The Cambrian explosion and the appearance of a controlling brain in creatures. A few minutes later, we have the first land plants, followed by the first creatures exploring the land from the ocean. We're at 11:24 already, and the land has just started to show some color. About 11:35, 25 minutes to midnight, we see dinosaurs taking their place at the top of the food chain. Then by 5 minutes to midnight, a giant asteroid has wiped out about 90% of all living species at that time. There are no more dinosaurs, but it gives room for other complex creatures like elephants or even humans. 20 seconds to the end of the day, our lineage, our ancestors diverged from apes and orangutans. It's not until 1 second until the end of the day that we, our species, Homo sapiens, begins their walk out of Africa. On this timescale, Stonehenge and the pyramids, the first complex structures, were 300ths of a second to the end of the day. Einstein, he occurred 1,000th of a second before midnight. That's a very brief history of our universe. In one real solar day, we have 400 million people having sex. 400,000 babies are born and 200,000 people die. That doesn't balance, does it? 30,000 people die from hunger and 100 unique species become extinct in one solar day. My question is, will we be here for 1 second after midnight on this timescale? Well, let's see what's in store for us in our future. The next big cosmic event is this thing. This is our nearest neighbor. It's the Andromeda Galaxy. It has about 400 billion stars, and it's heading towards us at about 120 kilometers per second. On this same timescale, it's going to collide with us at 3 a.m. in the morning. And I'd like to show you a computer simulation of this carried out by my colleague John Dubinsky with some strange guitar music by myself. So each galaxy is represented in the computer with millions of stars. They're surrounded by giant dark matter halos that you can't see, and what you're seeing is hundreds of millions of years of evolution every few seconds. You can never witness this in real life. It takes a long time, an astronomically long time. But with our computers, we can follow the full future of such events that take place like this. The colors show you the local number of stars. So these tails and streams that are being pulled out of the galaxy really are stars and solar systems that are flung out into empty space by the gravitational collision that has taken place. So our galaxy in the future undergoes this giant collision, and we see galaxies colliding today, and we see the end product of these galaxies, a giant elliptical thing like this. This is what our galaxy will look like in the future. We will probably survive that. Only a few thousand stars actually collide head-on in that collision we just witnessed. Quite a few planets will get ejected into space, though, well away from their parent stars. But that's not the only thing that we will have to face in our future as time passes by. Stars don't live forever. They burn through their fuel, fusing hydrogen atoms to form helium, carbon, oxygen, etc. All the atoms and elements we're made of, apart from hydrogen. Each step generates more energies, and the stars get brighter and brighter. So if we look at the age where we are now, this 0 is the beginning of the solar system, our sun, 4.5 billion years is here, then the brightness of the sun is increasing over time, and this means it's getting warmer on Earth. It also means it was colder in the past. So a few billion years ago, Earth looked rather like Venus here. But the presence of life and plate tectonics turned it into quite a different object. As time goes on, the sun is getting brighter and the surface of our Earth is getting hotter. And what this means is that by about the same time as this collision is undergoing, about 2 o'clock in the morning, it's so warm on Earth that all the water has evaporated and the surface becomes barren again. And there's not much water. Just if you can see, this dot is the total amount of water on Earth. The smallest dot is the total amount of surface fresh water. It's a rather precious resource, and it will all be gone early in the morning of the next day. So we've already had over 3/4 of our time on this planet. By 8 o'clock the next day, the sun switches off, 7 billion years from now. It turns into a red giant. So before it fades and dies and becomes invisible, it turns our Earth back into a molten rock, something like it looked like soon after it formed. The final death of the sun is quite beautiful. You see these nice pictures taken from the Hubble Space Telescope, the planetary nebula. Our sun will end up looking like this one day as it gives its last dying gasp and blows off its outer shells. By this time, if our future relatives are still around, they need to find a new home. Our solar system is not a good place to be. It's a tricky thing. The nearest star at the moment is Alpha Centauri. It's 4.5 light years away. In a commercial jet, that would take 1 million years. Even in a space shuttle, it's going to take you 100,000 years, which is a little bit longer than most people are prepared to wait. If we could build a spaceship that could travel at 10% of the speed of light, then we could make that journey in about 40 years. That sounds much more promising. Of course, that's a technological problem of an immense scale, but in fact we could build such a spaceship today. We have the technology to do that. It was actually developed in the 1960s, Project Orion, by Freeman Dyson and other scientists to design an interstellar space mission. This was their spacecraft here and designs. It was never tested due to a global treaty that didn't allow nuclear weapons to be used in space. And that's a shame, because that's how this thing gets its power. There's a big steel plate at the back, and you literally throw nuclear bombs out the back, and the blast wave accelerates you up to, well, after you've thrown about 10,000 giant bombs out the back, you're reaching a speed about 10% of the speed of light. There are better ways, but still, that is a possible one already. So, where would we go? And I mentioned at the beginning already that our galaxy is literally filled with stars, and many of those stars have planets. So, there's a lot of homes for life in our galaxy. This is the Kepler orrery, which shows some of the planetary systems that have been found already. And there's an immense number, and they all have different properties. Some are smaller than our own solar system, some are larger. But can we stay at those homes? How long can we live in our own galaxy? We have to go to the day after tomorrow on this time scale. So, what happens in our far future? As a species, there's nothing to prevent us existing for billions of years. We can merge our minds with machines that would enable a strange sort of longevity. But one thing that's coming up is that the dark energy we've heard about, this mysterious energetic nature of space that causes it to be pushed apart exponentially quickly, will lead to the strange occurrence in the future that it will cause all the galaxies beyond our Milky Way to disappear from view. Any scientists, observers left in our galaxy in the distant future will only know about our own Milky Way and nothing beyond it. And as time goes on, we've come to the point in our galaxy that we've reached the last star has used all of its energy and switches off. That happens about the same time as the dark energy expands our universe out of view. There's darkness everywhere, no source of energy. It sounds pretty bleak. Are there any alternative theories? After all, we don't understand many things. We don't really know what most of our universe is made of. We don't understand what happened and caused the Big Bang. We don't know why the universe is so finely tuned to give conditions that are suitable for life to arise. Our understandings of particles, space, and time is very poor. Quantum mechanics and gravity, forget it. We haven't had a clue about how to link them together yet. It's a strange universe. Are there any other solutions? Well, there is one. One is that we're actually living inside of a matrix, and some advanced civilization is doing a computer simulation, trying to understand their origin, and we are inside of that creation. That's the only other model besides the Big Bang that is consistent with all the observations. I quite like that one. The multiverse is another idea which explains some features of our universe. If you have an infinite number of universes, you're going to get one that is the properties right for life. Well, that doesn't really answer much, and it doesn't change the future of our patch of the universe. Everything is still going to become dark. So, at the very end now, we're at past the last star. Even the longest lived objects, black holes, decay by Hawking radiation. With no source of energy, all life must ultimately die, since all life requires energy just to think. So then, what is the purpose of life? If life can't exist 1 trillion years from now, and the universe is infinite in age, perhaps, we're only occupying a very brief window inside of the time-space of our universe. It seems to me that there is no purpose to any of this. Our existence is just a chance, a result of the laws and rules of physics. It's bizarre, an astonishing chance. Our bodies and our minds are the one possible optimized path that propagates a useless DNA molecule and hosts all of our bacterial friends. Apart from that, there's really not much point to it all. But it is a special universe to be in, and it's extremely special to be alive. So my last words is just to make the most of your life and time on this planet, because it's quite short. Thank you.